Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, we are going to see about maximum power transfer theorem. This theorem is one of the useful circuit analysis method to ensure maximum amount of power delivered to the load resistance. For DC circuits, this theorem states that the DC voltage source will deliver maximum power to the variable load resistor only when the load resistance is equal to the source resistance, that is Thevenin's resistance of the circuit. For AC circuits, it states that the AC voltage source will deliver maximum power to the variable complex load only when the load impedance is equal to the complex conjugate of the source impedance. This theorem is applicable only when the load resistance is variable. Suppose if the source resistance is variable, we have to choose the resistance which is very low from the given options. The circuit used for maximum power transfer is the Thevenin's equivalent circuit. Here VTH is the Thevenin's voltage and RTH is the Thevenin's resistance. RL is the variable load resistance. Here figure B shows the variation of power delivered to the load with the load resistance. We can see that maximum power is delivered to the load only when the load resistance is equivalent to the Thevenin's equivalent resistance. For DC circuits, the maximum amount of power transferred to the load can be calculated by using the formula PLmax is equal to VTH square divided by 4RL or VTH square divided by 4RTH. Here VTH is the Thevenin's voltage and RTH is the Thevenin's resistance. The efficiency of maximum power transfer is 50%. Let us understand this maximum power transfer theorem by solving a problem. The problem is find the maximum power that can be delivered to the load resistor RL of the circuit shown in the following figure. Here the voltage source is equal to 30 volt, current source is equal to 2 amps, the resistors R1 is equal to 3 ohm, R2 is equal to 3 ohm and R3 is also equal to 3 ohm. The options are 30 watt, 45.5 watt, 24.5 watt and D15 watt. The correct answer is C, 24.5 watt. Let us see how we got this option. For maximum power transfer, we have to represent the circuit by its Thevenin's equivalent circuit. So first we have to find the Thevenin's voltage. For that we have to remove the load resistor and find the open circuited voltage across the terminals. That is the Thevenin's voltage. Here applying Kirchhoff's current law, which states that the algebraic sum of currents at any node or junction is equal to 0, or the algebraic sum of currents entering the junction or node is equal to the algebraic sum of currents leaving the junction. So here if we apply Kirchhoff's current law, we have the leaving currents, that is VTH minus 30 divided by 6 plus VTH by 3 is equal to the entering current 2 amps. So VTH by 6 minus 30 by 6 is equal to 5 plus VTH by 3 is equal to 2. Simplifying, we have VTH is equal to 14 volt. Hence the Thevenin's voltage is 14 volt. Next step is we have to find the Thevenin's resistance RTH. For that we have to remove the load resistor and short circuit the voltage source and open circuit the current source. Short circuit means voltage will be 0. Open circuit means current will be 0. Now the resistors R1 and R3 are in series and their equivalent is in parallel with resistor R2. So RTH is equal to R1 plus R3 parallel R2, which is equal to 6 into 3 divided by 6 plus 3, since R1 plus R3 is equal to 6. So RTH is equal to 18 by 9 is equal to 2 ohms. Thus the Thevenin's resistance is 2 ohms. To find the maximum power transferred to the load resistor, we have to replace the given circuit by Thevenin's equivalent circuit. So we have got Thevenin's voltage as 14 volt and Thevenin's resistance as 2 ohms. Now the maximum power can be calculated by using the formula PLmax is equal to VTH square by 4RL or VTH square by 4RTH. Substituting for VTH is equal to 14 and RL is equal to 2 ohms, we have PLmax is equal to 24.5 watt. So maximum power delivered to the load resistor is 24.5 watt. Now let us see the previous year's questions. First question. This question was asked in June 2014. Superposition theorem. We know that superposition theorem is applicable to only linear systems. It is not applicable to non-linear system. So for this we have option 2. Next is Thevenin's theorem. Thevenin's theorem. Here for Thevenin's theorem we are reducing some portion of the circuit to an equivalent source and a single element. So for Thevenin's theorem, option 4 is valid. Next is reciprocity theorem. This theorem states that ratio of excitation to response is constant when the positions of excitation and response are interchanged. So for this, option 1 is valid. And next is the maximum power transfer theorem. And for this theorem, we are replacing the circuit by Thevenin's equivalent circuit. So for this, option 3 is valid. So for overall, we have the correct answer is option B. Next question is match the following type, and it was asked in June 2015. First one, superposition theorem. We know that superposition theorem is applicable only to linear circuits. It is not applicable to non-linear circuit. So here fourth one is not valid to power of the circuit because power is a non-linear quantity. So for superposition theorem we have the correct one is fourth one. Next is maximum power transfer theorem. We know that for AC circuits maximum power is transferred from the source to the load impedance only when the load impedance is equal to the complex conjugate of the source impedance. And next one is Norton's theorem. We know that in Norton's theorem we are replacing the circuit by a single ideal current source with a single parallel resistor. And next one is reciprocity theorem. And this theorem states that the ratio between voltage and current is constant in different loops. So option C is valid. Next question is, for the circuit shown below, the value of RL and maximum power R. This question was asked in November 2017, and here they are given the voltage source as 10 volt and resistor values are 20 ohm, 90 ohm, 60 ohm and 180 ohm, and variable resistance is given. So we have to find the load resistance and also the maximum power that is transferred to the load. So the options are 6 ohm and 0.51 watt, 12 ohm and 0.6 watt, 12 ohm and 0.75 watt cannot be calculated without knowing RL. Here the option C is correct. Let us see how we got this. To find the maximum power transfer to the load, first we have to replace the circuit by Thevenin's equivalent circuit. So we have to find the Thevenin's voltage first. For that we have to remove the load resistor and find the open circuited voltage across its terminals. Here, since all the resistors are parallel, the nodal voltage is equal to the Thevenin voltage. So, applying Kirchhoff's current law, we have the living currents, that is VTH minus 10 by 20 plus VTH by 90 plus VTH by 60 plus VTH by 180 is equal to 0, since there is no entering current. Now, taking 180 as LCM, we have 9 VTH minus 90 plus 2 VTH plus 3 VTH plus VTH is equal to 0. Simplifying, we have VTH is equal to 6 volt. That is, the Thevenin's voltage is equal to 6 volt. The next step is to find the Thevenin's resistance. For this, we have to remove the load resistor and short circuit the voltage source. Short circuit means at that terminal voltage is 0. Now all the resistors are in parallel. So the equivalent resistance can be calculated by 1 by RTH is equal to 1 by 20 plus 1 by 90 plus 1 by 60 plus 1 by 180. So this is equal to, taking LCM as 180, we have 9 plus 2 plus 3 plus 1 divided by 180, which is equal to 15 by 180. Taking reciprocal, we have RTH is equal to 12 ohms. That is, Thevenin's resistance is equal to 12 ohms. Next, to find the maximum power delivered to the load resistor, we have to draw the Thevenin's equivalent of the circuit. So after drawing that, for maximum power transfer, the condition is RTH should be equal to RL. Here VTH is equal to 6 volt and RTH is equal to 12 ohms. Therefore, RL should be equal to 12 ohms. The maximum power to RL can be calculated by using the formula PL max is equal to VTH square divided by 4RL, which is also equal to VTH square divided by 4RTH. This is equal to 6 square divided by 4 into 12, which is equal to 0.75 watt. So the maximum power delivered to the load resistor is 0.75 watt. The next question is, in the figure below, the value of load impedance ZL, which will cause maximum power to be transferred to the load is. This question was asked in June 2019, and here they are given a voltage source, resistor 2 ohm, inductance J2 ohm, capacitance minus J2 ohm, and another inductance J2 ohm, and the variable load resistor. The options are 2 plus J2 ohm, minus J2 ohm, 2 ohm, and 2J minus 2 ohm. Here the correct option is 2 ohm. Let us see how we got this. We know that maximum power is transferred from the source to the load when the load resistance is equal to the source resistance or Thevenin's equivalent resistance. So first we have to find the Thevenin's resistance. To find Thevenin's resistance, we have to remove the load resistor and short circuit the voltage source. After removing the load resistor, current through J2 ohm is equal to 0. So we are not considering that inductance J2 ohm. Now resistors 2 ohm and inductance J2 ohm and capacitance minus J2 ohm are in series. So RTH is equal to 2 plus J2 minus J2, which is equal to 2 ohm. So the load resistance is equal to 2 ohm. Hence, for maximum power transfer, the load resistance is equal to 2 ohms. Thanks for watching the video. For more videos, don't forget to subscribe our channel.